Hey everybody, Lloyd Rieber here with a bonus video from my course, Statistics and Education for Mere Mortals. In this little video, I am going to try to help you to think in terms of distributions. So by this point, we're well acquainted with these two very different types of statistics, measures of central tendency, such as the mean, median, and mode, and measures of variability, such as the standard deviation. But we have to be kind of careful here that we don't simply think in terms of simple numbers to represent something much more complex. And in fact, I think the tendency is to be thinking in terms of a single number, namely the mean or average. And I like to kind of emphasize why it's important to remember that we need both types of statistics and also to remember what they represent, which is a distribution of scores. So we're well acquainted with the idea of a normal curve and what it represents. And I hope you remember how we build or graph a normal curve. And it's simply by looking at all the raw scores and simply, counting up how many we have of each. And so if a particular measurement is normally distributed, you're going to get this bell type like curve. But there's no guarantee that you will. And so it's very important to remember that we need to be much more familiar with the data than simply assuming that we're going to have a normal distribution. But again, remember that we have a whole slew of scores, which is represented by all those little X's on this particular slide. And it really helps to emphasize why we need both types of statistics. So many times when we're thinking about our research or our evaluation, we might think in terms of groups, and we are so familiar and comfortable with the idea of computing a mean or average that we might fall into the temptation of thinking about a group as being that one number. So we have to always remember to think in terms of those distributions for each of the particular groups. And here you see three examples where group 3 is like a spike, and maybe we have a group of people who have come to the training or learning situation who maybe already know or have already mastered what it is that we're trying to teach. And so you have it, very narrowly grouped together. Just about everybody is attaining mastery. Whereas group 1, you see how much more widely distributed the scores are. You have a flatter type curve, and of course group 2 is more of a what you would expect in a normal distribution. But the numbers 32, 55, and 92 only tell part of the story. We need to be thinking in terms of the variability of those scores. And here's a little demonstration of what I mean. When you see the number 9, it's easy to wrap your head around that. 9 of something. I have 9 eggs left in the refrigerator, or maybe 9 ice cubes. But when I start thinking about maybe going out to lunch somewhere in town, I start thinking about restaurants and what I consider to be maybe the typical price for a lunch at that restaurant. So yeah, maybe $9 at one restaurant, but I think about another restaurant, it might be $13 would be typical. Another one maybe 8, another one maybe 19, another one maybe 20. So as I start thinking about this, I now have a group of scores, and I have to make sense out of that group. And, so far I probably could look at this and have a sense of that maybe the average is right around 11, maybe $12, hard to, maybe 10. And I see that they vary quite a bit as well. So it really makes a difference where I might go for lunch. But you can see how much more difficult it is to kind of wrap your head around that group of numbers to try to make sense out of it. And that's why we might like to have some statistics that are handy. So actually the mean or average is $12.14, and I see a distribution in terms of standard deviation of 5.37. And so it looks like it is somewhat skewed as well, because if the mean and median are not exactly the same or very close, then you know that you have a skewed distribution. So probably it's skewed toward we have some more expensive restaurants than we do typically. So yeah, so let's play a little game here to kind of show what standard deviation actually leads to. So let me start over with 9. And what I'm going to do this time is have all the numbers to be 9. Now, when I look at those statistics, well, the mean and median are exactly the same, and you notice that the standard deviation is 0. Well, that's because there is no variation. They are all exactly the same. So that already gives you somewhat of a concept of what standard deviation shows you. How, what's the variation? Well, there's no variation. Well, what if I change that 9 to an 8? Okay, so you see the standard deviation is no longer 0. It's now 0.3. Change the next number to an 8. Well, standard deviation is 0.4. Let's keep going. 0.47. 0.50. So it's getting bigger, but you might notice it's not getting, the increment is not as large every single time. Let's keep going. 0.52. Next. Didn't change. 0.52. Let's do it again. 0.50. It is now going down. Well, that's because the numbers are getting more and more alike. They were all 9s before, but they're now becoming all 8s. When I get down finally to my last 8, it goes back to a standard deviation of 0. So if you take this idea further and take a look at these 3 columns of numbers, but in this case, I have 1,000 numbers in each of the columns. As I scroll down, do you think you could somehow gauge what the mean or median might be, and also what the standard deviation might be? Now, one thing might jump out at you as I get closer to the bottom is that you can see that with a very rare exception, we only have 2 digits. So that gives me some sense of the range of numbers, probably going for, well, certainly no more than, in this case, 95 seems to be the highest number that I see here. But you might guess that this might be your typical percentage going from 0 to 100. But there really is no way to know just by looking at them what kinds of distributions you have. So at the very bottom here, I provided just the average and the standard deviation. So as you can see, the average varies quite a bit from groups 1 and 2 to group 3, and the standard deviation is quite a bit different in groups 1, 2, and 3. So those numbers are really helpful for me to get a sense of what's going on there. But there really is no substitute also from actually taking a look at a picture of the data. So here's another demonstration of why it's important not to simply consider the mean as the best way of representing a group of scores. So for example, let me show you 4 different distributions. And let's imagine that each one of these has a mean of 50. You can imagine it being a test or a quiz or something like that. And so in the first one, we can imagine drawing a normally distributed curve like that. And so in this case, the mean, median, and mode are all pointing at the same place. And so again, this is your typical bell curve. We could also have a bell curve that would be much more narrow. But again, the mean would still be 50, and you would have the median mode again being this single point up here. But what about a distribution that looks something like this? Well, in this case, again, that's still the mode. Here we have again the mean, but the median would actually be right there in somewhere between those two, which would be a better number to represent that particular distribution. But still, if I only looked at the mean, all 3 would be showing a mean of 50. And how about this particular distribution, if I can draw it well? This is called a bimodal distribution. Again, very different. Here you might have a case of two very different kinds of learners who have come to the training or learning situation. So you, in a sense, you have uh, a point that or a value that is better to represent each uh, part of that particular group, but yet the overall mean is still 50. Okay, well, I hope this little video is now helping you to think in terms of a group of scores or a distribution of scores when you are working with statistics.